We're going to look at example 1 from your notes, your class packet. So we're looking at horizontal projectiles. So these are projectiles that aren't shot at any specific angle. They're just shot at a perfectly horizontal trajectory. So this is saying there's a bullet fired with a horizontal, or sorry, with an initial velocity of 245 meters per second. The gun is 1.5 meters above the ground. So the first thing I want us to figure out is how long is the bullet in the air? Okay, so let's take a look at what we know. I'm going to draw a picture. So here's my gun. And I have a bullet flying out. And so I know that my initial velocity in the x direction is 245 meters per second. My initial velocity in the y direction for a horizontal projectile like this is 0. So it's not falling before it leaves the chamber of the gun. And when it's shot out, it only has an initial velocity in the x direction. I'm going to move this over just so I have more room to draw some other things. So my initial velocity in y is 0. Okay. The other thing we know is that the gun is 1.5 meters above the ground. So we can do our position here. I'll just do the y position of the gun and the ground. I'm going to call the ground 0. So I get to decide what my 0 point is, and I'm going to call it the ground. I know that the gun in the y direction is 1.5 meters above the ground. So I can put that there. I'm going to call my x where the gun was shot from. Yeah, I'm going to call where my gun was shot from x shot. And I'm also going to define that as 0. So my starting point is where the bullet leaves the chamber in the x direction. Where the bullet lands, I'll just call that x land, is, well, we don't know how far it's going to fly. So that's a question mark. The other thing that we don't know is how long the bullet is in the air. So you can call it t or delta t. The delta is implied. Okay? We know a couple of other things. Our acceleration in the x direction for this type of problem is always 0. And our acceleration in the y direction is negative 9.81 meters per second squared. So that's all of the information we know based on this scenario. And that's enough to determine how long the bullet is in the air. So the bullet, once it leaves the chamber, is moving really fast. It's moving 245 meters per second, but it's in free fall in the y direction. So gravity is pulling on it, and no matter how fast the bullet is moving in the x direction, it's going to be accelerating downward at negative 9.81 meters per second squared. So I can use my favorite equation. I'll do it in this kind of yellow color. So y equals 1/2 at squared plus initial velocity times time plus our initial position. So my initial position, where I'm starting from, is the chamber of the gun. And so I know the gun is 1.5 meters above the ground. I know my initial velocity in the y direction is 0. So that means that this whole term here is going to turn into 0, because if I do 0 times time, that's going to be 0. Over here, I know that 1/2, I know acceleration is negative 9.81, and I know that I need to figure out time because it's asking how long is the bullet in the air. The other thing I know is that my position of interest, or my final position, is when the bullet hits the ground, and I call that 0. So now I have enough information to just algebraically solve for time. So I'm going to subtract 1.5 on each side. So I have negative 1.5 is equal to, I'll multiply 1/2 and negative 9.81, so negative 4.905 times t squared. I'm going to divide by negative 4.905 on each side. So negative 1.5 divided by negative 4.905 is 0.306. So t squared is equal to 0.306. I'll take the square root of that to get the time that the bullet is in the air, and it's 0.553 seconds. So it'll take a little bit more than half a second for that bullet to hit the ground. So that's the answer to A. So again, we used all of the information we know for this type of problem. So I know that my acceleration in the y direction is negative 9.81 meters per second squared. I know that my initial velocity in the y direction is 0. I didn't know the time, but the question was asking me to find the time. And I knew that the change in position was negative 1.5 meters. My initial position was 1.5 meters, and my final position was 0 when it hits the ground. Okay. Next, they're asking, how far does the bullet travel before it hits the ground? This is implying the x direction. So I know some things here. I'm going to move this so that we can see everything with our picture. But I know that now my time in the air is 0.553 seconds. Okay, so basically we need to figure out, where does the bullet land? How far away from the chamber of the gun? So I'm defining my initial position as the x position of the chamber, and so I'm calling that 0. And now we need to figure out where this lands. So we're going to, again, use my favorite equation, but we're going to use it in the x direction. So I'll write out our equation. X equals 1/2 at squared plus initial velocity in the x direction plus our initial position. So our initial position is where we started, which we defined as 0. So this initial position term is going to go away. We can drop it. The other thing we can drop is we know that acceleration in the x direction is 0. So this whole term is multiplied by 0, so we don't even need to worry about it. So I don't know my final position, which is the landing spot, but I do know my initial velocity, which is 245 meters per second. That was given to us. And I do know how long the bullet is in the air, 0.553 seconds. Again, the acceleration term is dropped because acceleration in the x direction is 0, and our initial position was 0. So all we have to do is multiply 245 by 0.553, and that'll tell us how far we flew. So I got 135.5 meters. And that's it. So that's how far the bullet travels before it hits the ground.